Okay, this is what exam questions can look like. So we've got two people who are in the cricket team. They play for the club's under-18 team. And we've got the probability that Alec is selected. We've got the probability that Eric is selected. And we've got the probability that both of them are selected. And it gives us a big hint to use a table. So that's what we're going to do. So, all right, what's our table going to look like? Well, I'm obviously going to have columns. And one of the events is going to be that Alec is selected. Okay, now, because Alec and Eric maybe both could be selected, I don't want to put Eric here as an alternative to Alec. It could be something that happens as well. So it must be Eric being selected is there. And then the rest of the table must be for Alec not being selected and for Eric not being selected. And then I always need a total. Row totals, and we'll have column totals. And here we'll have the grand total. Now we're working with probability, so I know when that happens the grand total is going to be 1. So let's fill in the table. The probability that Alec is selected is 0.85. Now that pays no attention to Eric or not Eric, so that must be the total probability for Alec is 0.85. Okay, and at the same time I could fill in the total for not Alec. It's got to be 1 minus 0.85 to make this total of 1. So 0.15 here, I can fill in straight away. And then the probability that Eric is selected to play is 0.6. So that's, we don't care about Alec at this stage, we just want the overall probability for Eric, and that's 0.6. And then the last one is the probability that they're both selected to play is 0.55. So that's this cell here. Okay, that's them both being selected, 0.55. Okay, I could have filled this one in next, but in fact now I've reached the point where I can just work my way through the table, subtracting from the total. So this must be 0.05, which gives this one must be 0.10. This one taking away must be 0.40, and this one I've got a choice of 2 directions to take away, but either way I get 0.30. So I've got my table nicely filled in. Okay, so now let's answer some questions. So, show that the probability, okay, that neither twin is selected is 0.10. So the probability of neither being selected is that Alec isn't and Eric isn't. And in the table, it's just this probability here, 0.10. Now, it's a show that question. The answer was given in the question, but my table shows all the working out necessary. So I'm going to get credit for that. Normally, you want to make sure you've shown some working, and I have. I've shown it in the table. Find the probability that at least one of the twins is selected for a particular game. Now I could work out the addition of 3 probabilities, but there's that nice trick where you do the probability of at least 1 by saying the only way that could not happen is if neither was selected. So 1 minus the probability of none or neither. Okay, this works with more than 2 events. So at least 1, I should say. Probability of at least 1 happening is 1 minus the probability that none of them do, which is 1 minus the probability that neither plays is 1 minus 0.10, which is 0.9. Then I've got to do part 3, which I want to find the probability that exactly one of the twins is selected for a particular game. So the probability of exactly 1, okay, is either Eric but not Alec, which is here, or Alec but not Eric, which is there. So I need to do 0.05 plus 0.30, which is 0.35, which is my answer, so I'm happy. Okay. Then we want the probability, okay, in part B, we're moving on to this. Let's read it actually. So in part B, we've now got information about Cedric. So we've got various probabilities, which are all conditional ones, depending on whether both the twins or one of the twins or neither of the twins has been selected. So calculate the probability that for a particular game, all 3 brothers are selected. Okay. Now I could do this as a big tree diagram. Okay, but I can kind of avoid that. I'm sort of imagining a tree diagram. I need to think how this could happen. So for B1, all 3 are selected. So imagining part of a tree diagram, I could think that okay, for that to happen before Cedric's selected, we need Alec and Eric both to be selected. In fact, I'll write A and E in probability notation. And I already know the probability that both Alec and Eric are selected. It's in my table here, it's 0.55. In fact, it was given right near the top of the question, I think. So that's the probability that Alec and Eric, the twins, are both selected. And I want all of them to be selected. So now, my next part of my tree, if I drew it in full, would have Cedric being selected, okay, or Cedric not being selected. Well, I want Cedric to be selected, okay, and if both of the twins have been selected, he's got a 0.3 chance of being selected. So this route through the tree would be 0.55 times 0.3, which is going to be my answer. So 0.55 times 0.3 is 33 over 200, or 0.165, 0.165. I'm just going to give that as my answer. Okay. All right. And then B2, okay, we want at least 2 of the 3 brothers are selected. Okay. Well, one way that could happen is the one I've already done. Okay. That they're all 3 selected. Okay. But now I need to consider the probability that it's just 2 out of the 3. Okay, so one way of that happening is that both the twins are selected and Cedric isn't. So I can just carry on with the tree I was doing before, which is 0.7. So I could do 0.55 times 0.7. Okay, all right, that's one way it could happen. Or we could have it so that one of the twins is selected and Cedric isn't. Okay, so what's the probability that one of the twins has been selected? So once I know that, I know the probability of Cedric being selected is 0.75. So the probability that one twin is selected, I've kind of done this before, okay, because I worked out the probability that exactly one of the twins is selected in dotty 3. I did it by adding these probabilities. So this answer of 0.35 is actually the probability that one of the twins is selected and the other isn't. So if that happens, I now need to get exactly 2 of the brothers to have played. I now need to multiply that by the probability that Cedric plays, given that one of the twins has been selected. So that's times 0.75. So this is 1 of A and E plus Cedric. Okay. This one here was both of A and E, but not Cedric. So this is A and E, not Cedric. Okay. And the other possibility, which we mentioned before, is the probability that all 3 of them play, which I've already got is the 0.165. So that's one way of breaking this down into different ways it could happen, which I can now add up. And I could have done it with a big tree diagram, but this is a bit more economical, I think. So I've got the 0.1365 that I had before, and I need to add on the first one, the 0.55 times 0.7, and I need to add on the third one, the 0.35 times the 0.75, add them all up, and I get 13/16. Okay, or as a decimal, 0.8125. Either form is fine for the answer. So we're done.